Now, after exploring CSRF attacks, let's move on to XSS attacks. XSS stands for cross-site scripting, so the X stands for a cross because, well, it looks like a cross. And cross-site scripting attacks are all about injecting malicious JavaScript code into the content of a website. So we got our typical setup, let's say, where we have a backend, maybe talking to a database or some other data storage. And we got a client, so a browser requesting a website from our backend, from our server, and then some website is displayed in that browser. Now, the content that is displayed will very likely be fetched from our database or from some other data store. So the server, the backend, renders, let's say, a template and therefore produces HTML code, which is shown to the user, to the visitor in the browser. And that content that is rendered, so the content of the generated HTML file, is very likely fetched from some data source. For example, if you're building a blog, then the blog posts, the list of blog posts and the individual blog posts are coming from a database, for example. That's what we built before in the course already. Now, with an XSS attack, as an attacker, we try to sneak some malicious JavaScript code into the content that will be part of that generated page, so that this rendered HTML page contains malicious browser-side JavaScript code, which is therefore executed when that page loads in the browser of a visitor. And therefore it executes for every visitor in their browsers. And since browser-side JavaScript is very powerful, for example, you could use it to send AJAX requests and then send all kinds of requests to, again, send money or anything like that, this is a real problem. Now, again, I prepared a project here into which we'll take a look, where I will show you this attack pattern and what the problem with it is. It's in this XSS folder, which was part of the project you found attached earlier in this course section. And in there, you got another Node-Express application. Again, cross-site scripting attacks are not exclusive to Node-Express, though. Any website can be vulnerable to that. And here we got a very basic site. We, for example, don't have authentication in there anymore because it really doesn't matter. Now, if your site does have authentication, then XSS might be able to do even more damage, because with that injected JavaScript code, you would be able to, again, send requests on behalf of the authenticated users to, for example, send money somewhere. But again, it's not technically required. Authentication is not technically required to be vulnerable to XSS. And therefore here, for simplicity reasons, to keep that code a bit more simple, I actually omitted authentication. But with or without it, you can have XSS vulnerabilities. Now, if we have a look at the routes we got, it's very simple. I just got 3 routes in here. One for redirecting to /discussion. And on the discussion page, I'm fetching a bunch of comments from a comments collection. Again, here I'm using MongoDB, so if you want to follow along, you need to have MongoDB up and running. And then here in the post route, we actually handle the submission of a new comment, and then it's added into the database. And the dummy website we're building here is a very simple discussion platform where users can submit comments and see the comments of others. In the views, I only got one main view here, and that is a view where I output all the submitted comments and where I have a form for sending a new comment. As a side note, here you should definitely also add that CSRF token, because every website should protect against CSRF, and therefore every form in every website should have a CSRF token. I just don't have it here because with this example, I'll specifically focus on XSS, but you definitely would want to have your CSRF token here. So that is a must-have for every website, and we'll see it again later in the big course project which we'll build. But for the moment, let's focus on cross-site scripting attacks. And to show you how that works, again, I'll open this integrated terminal in VS Code, and I'll navigate into the XSS folder, and there we can run npm install to install all dependencies, and then npm start to start this server. If you now go to localhost 3000/nothing, you'll be redirected to /discussion, and there you should be able to submit new comments, and then you see the comments here. Again, it's a very basic site, definitely not fancy at all, but this is really not about the styling or anything like that. I just want to show the basic attack patterns. Now, here we got this form, and what happens on this site is, of course, these comments, which are output here, are user-generated content. All these comments are generated by users. So we take some user input, and we then save that in a database, and then we serve that user input back to our visitors. And of course, all visitors would see these comments here, not just the visitor who left the comment. And even if you had authentication in place, then maybe not all visitors are able to send a comment. They might need to log in first. Or maybe they can't all see the comments. They might need to log in for that as well. But in the end, if they are logged in, they might have that same behavior which you see here. Which is why I omitted the authentication process, because it simply doesn't help us here. Because the attack pattern which I'll show you will work either way. What if I don't enter some plain text here, but I decide to create a script here? I write some script code, and here I'll just send an alert where I say hacked, like this. This is valid JavaScript code, and now I'll create a comment that contains that code. Of course, this alert isn't doing anything fancy. Indeed, it will actually show visitors that something is fishy on this page if they load the page, but it's just here to show you that executing such scripts on a page might work. In reality, you would probably not show an alert here, but maybe send an AJAX request, which then could also use your session, because cookies also get sent along with AJAX requests, and which then would actually also not be guarded by your CSRF protection, because if this script would send an AJAX request, then the script runs on the correct page, and therefore it has the CSRF token. Because unlike with the CSRF attacks I showed you before, now we're adding some code here which will not run on a different page, which doesn't know the CSRF token, but I'm about to add some code here which will be part of that same official page which all visitors will visit, and therefore it will have access to the CSRF token, which would be part of a hidden input field, for example. But let's take a step back and let's send this and see what happens. You see, I got this alert here. I got it once the page reloaded. And here we see this second blog post, which doesn't seem to have any visual content, but if we inspect it with the browser DevTools, we can see that in there, in the second list item, I got this script, and this got executed. And again, here I just used it to show an alert to prove that it works, but we could be doing far worse things in there, like sending an AJAX request to some route of this page. And since we have the cookie and the CSRF token and everything, that could work, and we would have no protection against this. That's why cross-site scripting attacks are super dangerous, because they run on your site. They run on the official site, and they run there because some user managed to inject some malicious JavaScript code into your page. And you are vulnerable to this attack whenever you're outputting user-generated content. Whenever users submit posts or comments or news or whatever it is, and you then have a part of your page that outputs that content, you have a potential vulnerability. And I'm not just talking about complete blog posts. Whenever, anywhere on your page, you're outputting any user-generated content, you have this potential vulnerability.